Good afternoon, everyone. Thank you for joining us today. I'm UX Moto from Daisho. She is Ringu Yoshida from also Daisho. Today, I'll talk about use of 3D data in slope disaster mitigation. This is today's agenda, and middle of this presentation, we will do some actual demonstration in the middle of this presentation. First, introduction. Today's purpose is to highlight practical case studies demonstrating how latest technology facilitates smooth and safety progress. So, through this presentation, I'd like you to know about the technology we are using in Japan. 10 changes. Climbing slope for surfing. As you can see, these photos, people need to climb to high place for survey. So this task requires a lot of time, and also this is so dangerous task. So we tackle these challenges using 3D data. This is actually data from the site. So it looks like a photo, but taking a closer look, you notice that this is actually a point clouded data. From now, we will do some demonstrations with actual data set with her. First, let me show you the data before the slope disaster prevention work. This is the overview, and we can go closer. As you can see, the surface on the slope exists as point cloud data, and by selecting 2 points, we can create a cross section anywhere and any length, like this. So we can check the cross section of the surface and understand its shape like this. We can cut a cross section anywhere and any length like this. We only need to choose 2 points. And also, we can calculate the area choosing widths like this. We can calculate the area. And next, I will show you the data after slope disaster mitigation work at the same site. After the construction is completed, surveying is necessary to verify whether the work was carried out as per design. So we use this data for that purpose. We only need to select 2 points for surveying. Like this. We can measure it with this data. And since this data meets the standard set in Japan, we use it in actual construction. So as you can see, this data captures all angles without blind spots, ensuring sharp and accurate shapes like this. This is the actual select. Demonstration overview. Create cross-section at any angle and length, and don't need to go to the site for measuring. All of these tasks can be performed on the computer. accuracy within 10 millimeter of the length measured on site. That's why this data set satisfies Japan's standard. So we can use this actual construct site. So how is the data generated? We have two ways to generate this data set. First, laser survey, and second, photogrammetry. And this second one is the data we used in the demonstration was generated this way. So this is the most important part. What can be done with this data? After obtaining data, surveying can be done anytime on the computer. So continuous surveying without prolonged construction interruption. Also, we can use this data for management of completed construction site. For example, component quality management. But I discuss about this later. And also, we can monitor change in the site when disaster occurs. We can easily compare data before disaster and after. So if there are some problem, we can notice that. Collecting data beyond the reach of human capabilities. Imagine in case of the large-scale site, it's extremely challenging for us to measure everything. However, using this data, we can measure it anywhere in partial areas. Getting additional data anytime without reaching site. Before this technology, if additional survey were needed, it was necessary to go to the site each time. However, with this technology, additional survey can be done at the office. So we don't have to go back to the site. Creating cross-section at any angle and length. As shown in the demonstration, we can create cross-section anywhere and any length. So we are always asking this question, is this data accurate? The answer is yes. The data set meets the standard set by Japan within 10 millimeter of the actual survey measurement. So we can use this actual construction site. And also we sometimes ask this question, can this data be used even when the ground is covered with trees like this? The answer is yes. By posting the data and removing some points, as you can see, we can create the ground surface like this image. So let me introduce you some case studies. First, that's stream construction survey. In this process, several individuals are required to climb the hills like this, and these people holding the tapes. So this method would take 60 hours with 4 people. So, but now with our technology, we can do it on computers. So using these 3D models, the survey can be completed in 2 hours with 2 people. So we don't need 4 people and 60 hours. Case 2, management. We can manage component with 3D data. Just assigning color to the position of component, we can easily count this on the computer. So my conclusion, we plan to use this technology at the pilot site in the Philippines, and we will continue our effort to achieve a sustainable and better future. Thank you for your attention, and if you have any questions, we will have a Q&A session, and feel free to send any additional questions or comments to this email address. Thank you so much.